Hello and welcome to this video. So we are going to proceed from where we left during the last video, and that is question number 20. So straight away let's get to question number 20. So question 20 states that the figure below is a right pyramid VEFGH with a square base of 8 centimeters and a slant edge of 20 centimeters. And then we are told that points A, B, C, and D lie on the slant edges of the pyramid such that VA is equal to VB, which is equal to VC and VD, and each one of them is 10 centimeters. And then plane A, B, C, and D is parallel to the base, which is EFGH. So let me try to draw this pyramid, though I'm not so good at drawing, but I hope I'm going to make it. So there it is, just a sketch. So this is point V, then we have F, G, H, and then here we have point E. Okay, then we have point A, okay, at this point, that way, okay, that way. We have, this is A, this is B, this is C, and at the back here we have D, okay. So we are given that the slant length of this pyramid is 20 centimeters, and from V to A, okay, this point V to A is 10 centimeters, okay. And then we are also told that all these edges VA, VB, VC, and VD are equal, and each one of them is 10 centimeters long. Okay, so let's look at the first question. The first question states that find the length of AB. So where is AB? AB is this length, A to B, okay, A to B. So how are we going to get the length AB? Okay, then also we have FG is 8 centimeters, okay, 8 centimeters. So we are required to get AB. So we are going to use the knowledge on similarity and enlargement. I remember we have been talking about, or we have covered similarity and enlargement. I created a video where I taught you, or we learned about the linear scale factor, area scale factor, and volume scale factor, and all those. If you never happen to watch that video, I'm going to leave a link for you in the description box. Okay. So let's have these triangles. Let me extract a triangle. Okay, let me extract this triangle here. So this is V, F, and G. Sorry, not H. V, F, and G. Can we all see that triangle? Okay, this triangle. V, F, and G. So, and then we have this point. This point is A, and this is B. Okay, then F and G, F to G, we know it's 8 centimeters, and then VH, okay, V to G is the same as V to H. So V to G, it means that it is 20 centimeters, okay, from V to G. So now we are going to use the knowledge on similarity and enlargement, and what we are going to do is that we have two triangles, okay, two triangles that way. One is bigger and one is smaller. So the bigger one is V, F, and G, and the smaller one is V, A, and B. Okay, so how do we apply the knowledge on similarity and enlargement? So we're going to use the linear scale factor. So we know that this length is 8 centimeters, This one is 20 centimeters. V to B, we know it's 10 centimeters. So we are required to get AB. We are required to get AB. So we said that when we talk about the linear scale factor, if we take one length of this big triangle and then we take the same length of the other small triangle, that ratio of those two lengths is the same as if we would take any other length on the big triangle and one other on the small triangle. So what do I mean? So let's get the ratio between VG and VB. Okay, it's going to be 20 divided by 10. So that ratio is equal to, if we take FG and AB, okay, FG is 8 centimeters and AB we don't know, let's call it X. So we can get the value of X, which is the length AB, okay. So this is going to be 20X is equal to 80. So if we divide through by 20, we're going to get X as 4 centimeters. But X is the value of, or is the length AB, the length AB, which we are required to find. So AB is 4 centimeters, okay, AB. So back to our pyramid, you can see where AB is. AB is 4 centimeters, okay. So we can now proceed to the second part of this question. It states that calculate to 2 decimal places the length AC. Where is AC? Where is AC? The length AC, I can see that it's the diagonal from A all the way to C. Okay, can we all see that diagonal? The diagonal of this square plane, which is A, B, C, and D. So to make our work easier, let me extract that plane. Let me extract that plane. So let me clear some space here. So if I extract that plane, it looks something like this. Okay, it's a square plane. Okay, though it's not that perfect. And it measures 4 centimeters by 4 centimeters. So this is A, this is B, this is C, and this is D. Okay, can you all see that? We were already told it's a square. So AB is equal to BC. Okay, then we are saying that AC is this diagonal. So I believe you can already guess where we are heading to. Okay, so since this is a square, I believe that all these angles are right angles, okay, because all the 4 angles of a square are 90 degrees each. So I can see that I now have a right angled triangle measuring 4 centimeters by 4 centimeters, okay. So does that mean that I can get the hypotenuse of this triangle, which is equal to the diagonal that we are told, AC? Yes, we can. And we are going to use the Pythagoras Theorem. Have you ever heard of the Pythagoras Theorem? It states that if we square these two sides, so let me see this, so this is A, this is B, and this is C. So if we square AB, and then we add to the square of BC, we're supposed to get the square of AC. Okay, so that is the Pythagoras Theorem. So let's apply it to get the length AC. So AB is 4 centimeters. So 4 squared plus BC is also 4 centimeters. So 4 squared is equal to AC squared. Okay, so this is going to be 4 squared is 16 and 4 squared is 16. Okay, so this is equal to AC squared. So 32 is equal to AC squared. So what do we do to get AC? We can get the square root of both sides. So that AC becomes the square root of 32. The square root of 32 is 5.65. Okay, we have 656, sorry. 656. But then we are told to give our answer correct to 2 decimal places. So AC is going to be, so if we round off this one, it's going to be 5.66 centimeters. And that is going to be the length AC. The length AC. Okay. So we are through with that part. Let's move on to the next part of the question. It says that calculate, correct to 2 decimal places, the perpendicular height of the pyramid VABC. VABCD. Okay, VABCD. The perpendicular height. So what do we mean by the perpendicular height? So just look at this diagonal that we were working, that we have gotten the length, okay, AC. Can we all see that diagonal AC? So when we talk about the perpendicular height, we mean that height or that length from at the center here, at the center of this diagonal to the top or the tip of this pyramid. Okay? From the center of this length or the middle point of this length to the tip of the pyramid. So how are we going to get that length? In fact, let me extract that shape or that figure so that we can be able to understand it in a better way. So I'm going to extract the triangle VAC. Can we all see that triangle VAC? So that triangle looks like this. Looks like this. It looks like this, something like this. Okay? So that is the triangle we are interested in. This is V, this is A, and this is C. Okay? So we already know that VC and VA are equal. Okay? And each one of them is 10 centimeters. 10 centimeters. So the perpendicular height, okay, before we go there, the perpendicular height that we are interested in is this one. Okay? This perpendicular height. This is the center. This is the center point or the middle point of this diagonal AC. So this is the height that we are interested in. How are we going to get that height? So the reason why I've said that, or we are told that VC and VA are equal, we are supposed to realize that this is an isosceles triangle. So when we talk about an isosceles triangle, it has 2 sides which are equal. Okay, like these ones. And one thing about an isosceles triangle, if we bisect it this way, the angle that is formed here is 90 degrees. Okay? And then this line AC is divided into 2 equal parts. So we already know that AC is 5.66 centimeters. Okay, from our previous question. So if we divide this length by 2, okay, 5.66 by 2, it's going to be 2.83. So each one of them is 2.83 and this one is also 2.83. So I can see that I can now have a right angled triangle with the hypotenuse as 10 centimeters and here as 2.83 centimeters. So we can still use the Pythagoras Theorem, okay, to get this height that we need, okay. So we are going to square, okay, back to our formula. I had written it somewhere here, okay. AB squared plus BC squared is equal to AC squared, okay, or the hypotenuse squared. So that means if we square the hypotenuse and then we square this other side, which is 2.83, sorry, it's not 100, it's, okay, the square of 10 is 100, okay, the square of 10 is 100, okay, so it's 100 minus 2.83 squared, okay, 2.83 squared is so we have 100 minus 8.0089. Okay, so this is equal to 91.9911. so if we square these, we are going to get this length that we are interested in. So let me, not we square, but if we find the square root, so the square root of 91.9911 is 9.591, okay, centimeters. But then we are required to give our answer correct to 2 decimal places. So if we round this off, it's going to be 9.59 centimeters. So that is the value of the length, the perpendicular height of that small pyramid, that is VABCD. Okay, so let's move on to the final part of this question. Okay, let me clear this. Let's move on to the final part of this question. Okay. Okay. So the final part of this question states that if the pyramid VABCD was cut off, find the volume of the frustum ABCDEFGH correct to 2 decimal places. Okay, so we are told that this small pyramid was cut off. Okay, so when it's cut off, we are left with this frustum. So we are required to get the volume of the frustum that remains after the small pyramid was cut off. So to get the volume of a frustum, okay, I know we haven't looked at the volume of a frustum of a pyramid, but we have looked at the volume of a frustum of a cone, but there's no much difference. Okay, so we get the volume by subtracting the volume. Okay, we have the volume of large pyramid, and then we subtract the volume of the small pyramid, or the pyramid that was cut off. Okay, the pyramid that was cut off. So let's start by calculating the volume of the large pyramid. The volume of the large pyramid. So how do we get the volume of this large pyramid? So to get the volume of any regular pyramid, we need to get the area of the base. For this case, it's the base. The base is a square, and then we multiply by the perpendicular height. What do we mean by the perpendicular height? The perpendicular height is this height. Okay, remember we calculated the perpendicular height of the small cone. Okay, but we did not calculate that of the large cone. So the perpendicular height is this line that I have drawn in green. Okay, so this height from at the top here, the tip of this pyramid, cutting through at the center up to this point. Okay, but remember, we know the length of, or the height of, the perpendicular height of the small pyramid. So I believe we can get the height of the entire pyramid, and we're going to use the same concept of similarity and enlargement. This is what we're going to do. Okay, we know that the perpendicular height of this pyramid is 9.59. okay, that is what we found out. And then let's call, or let's name the remaining distance, or the remaining height as x centimeters from here to the bottom here. So in terms of x, the height, the perpendicular height of this big cone is going to be 9.59 plus x. Okay, And then we know the perpendicular height of the small cone. Is 9.59 centimeters. Then let's also pick one other length that is common for both pyramids. That is the large pyramid and the small pyramid. We can pick this slant length. We know the slant length of the large cone is 20, and the slant height of the small cone is 10. So what does that mean? So we have slant height of the big cone is 20, not cone but pyramid, and then the slant height of the small pyramid is 10 centimeters. So you can use the linear scale factor to obtain the value of x. So we just need to get the ratio of the two corresponding sides. Okay, the two corresponding lengths for each of those two pyramids. We can take the perpendicular height of the large cone and the perpendicular height of the small cone. So get the ratio. So we have 9.59 plus x divided by 9.59. So that ratio is the same as the ratio between any other two corresponding sides. So we can take the slant height of the big cone, it's 20, not cone but pyramid, sorry. And then for the small, or the slant height of the small pyramid is 10. So if we cross multiply this, we can get the value of x. So this is going to be 9.59 plus x, we multiply by 10, is equal to 9.59, we multiply by 20. So this is going to be 95.9 plus 10x is equal to 191.8. So like terms together, we can subtract 95.9 on both sides. Okay, so that 10x is going to be, so it's going to be 95.9. So if we divide through by 10, okay, x is going to be 9.59 once again. So that is the value of x. And what was x? X was the distance from here to here. So that means the entire height of that pyramid is 9.59, that is the height of the small pyramid, plus x, which is also 9.59. This actually means that that pyramid was cut at the center, okay, because the height has been divided twice, okay, and it's going to be 19.18 centimeters. So that is the perpendicular height of the large cone, of the large, not cone but pyramid. You guys will forgive me for this, I'm used to cones, but for this case we are talking about a pyramid. So we now have the perpendicular height of the large cone. So what we are now left with is the volume now, the volume. So we have now we have already the perpendicular height. So to find the volume of the big pyramid, we need to use the formula: a third multiplied by the area of the base, and then times the perpendicular height. Okay, perpendicular height. So a third times area of the base. So the base measures 8 centimeters by 8 centimeters. Remember, it is a square. So a third times 8 times 8, that is the area of the base, and then now times the perpendicular height, which is 19.8. So that is the volume of the big pyramid. What about the small pyramid? It's a third times, using the same formula, the area of the base. The base of the small pyramid measures 4 centimeters by 4 centimeters. So it's a third times 4 times 4, and then times the perpendicular distance, which is 9.59? Yeah, 9.59. 9.59. And then now we get the difference. We subtract this from this, and what we shall be left with is the volume of the first term. So let's work out this. Third times 8 times 8 times 19.18. You can use your calculators. So I can see that this one is 409.173 cubic centimeters. What about the small one, the small pyramid? It's 51.147 cubic centimeters. So let's get the difference. Let's subtract these two. What are we going to get? So it's going to be 358.026 cubic centimeters. Okay, but remember we are told to give our answer correct to 2 decimal places. So it's going to be 358.03. That is when we round off, and that is our final answer. So that is it for now. Thank you so much for watching this video. In the next video we shall pick up from the next question. So goodbye for now, and may you have a nice day.